term resistor describes a conductor especially chosen for its resistive properties. Resistors are most commonly used in electronic components. They are made in a variety of ways to suit particular types of application. Manufactured as either carbon composition or carbon filler. Here we have a carbon resistor. So you see these colours down here. We'll be going through how these give us the value for the resistors. You'll measure a resistor with an ohm meter, and it'll be from here to here with the probes. You have a metal thin film, which are a lot smaller and used in small electronic components. You also have a power heatsink, and they're for dissipating the heat the heatsink is used for. And then we have the explanation of the color code bands. There's 4 bands in resistors. So you have your first band, which is the first number, and then your second band is the second number, and your third band gives you your multiplier for the number of zeros you're going to have, and your fourth band is your tolerance band, which gives you your percentage band, which is the last one. So the first 2 are pretty simple, but the third one is where you get cut out. So we'll go into detail on that. And next is the color coding system. So they use black for the number 0, 1 for the number for brown. Red is used to represent 2, 3 is represented by the orange, and yellow is represented by 4, green represents 5, blue represents 6, violet represents 7, and grey represents 8, white representing 8. So we have come up with an easier way to memorize this, and it's here on the next slide. Now, mnemonic. You can either use try to be right, or your great big venture goes wrong, or busy brown ran over your there, while your grey walked. Next to all. Now, the fourth resistor color band indicates the resistor tolerance, which is commonly gold or silver, indicating a tolerance of 5% and 10% resistor, respectively. A 100 ohm resistor with a 5% tolerance will have a value of somewhere between 95 and 105 ohms, since 5% of 100 ohms is 5 ohms. If no fourth band exists, this indicates a tolerance of plus or minus 2%. So no fourth band, you just take it as a given, it's 20%. Not very accurate, but we'll go into that again. So the big ones to remember here is you have brown is 1%, red is 2%, gold is 5%, and silver is 10%. So when you start reading the resistors, you always notice you have a bigger space here beside the tolerance band. So this is going to be either gold, silver, brown, or red. Your first band then is going to give you your first number, your second band gives you another number, and then your third band is the number of zeros you're going to have. So this is what we need to memorize. Gold is 5%, silver is 10%, and no band equals 20%. I have a few resistors here on the board, so we'll turn this off, and here we go. In the first one we have green, so we'll write out Betty, brown, ran over your garden. Violet, grey, walk. So we use 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That gives our decimal from 0 to 9. So we've all numbers covered. So then we know brown is brown. So if we do 1, we do 0, 1, 2, 3, 4, 5, 6. That's it. So 0, 1, 2, 3, 5, 6, 7, 8, 9. So 0. 0, this B here will represent black. And brown says it's brown. This R here changes to red. 3O changes to orange. And 4 is Y, which represents yellow. 5 is G is for green, for garden. 6 is for blue. Violet stays the same. And grey stays the same. And walk changes to white. So the other easy thing is, remember black is here and white is here. So that's the first two you eliminate. Then you have brown stays the same, and violet and grey stays the same. So that's 4 straight away, and then it's very easy to fill in the others. So now we're going to go with first band is green. So we have green. Green from our chart represents number 5. So 5. So we have black. Black from our chart represents 0. And we have red. So red from our chart represents 2. So this is the zeros. So we'll have 2 zeros, which is like that. And then our tolerance band is gold, which is 5%. Gold. So gold, and then we have silver is 10%. And the next one is brown red. There is other colours, but you only need to go into that much detail. So gold is going to give us 5% here. So our true answer is 5,000 ohms, which can be written as 5 kV. That's the first one. So we'll go with the second one, which is red, black, green, and silver. So we'll go back to that. And red gold gives us 2. And black gives us 0. And green gives us 5. So we have 5 zeros. 1, 2, 3, 4, 5 zeros. And silver gives us 10% tolerance. 5,500 ohm. And that can be written as 5 or 500. Or, yeah, 5k first. Yeah, 5k, 5 ohms.
So, how did they change the resistance when you make them? How did they change the resistance? They're both at the same size. Is the composition of it?
The material.
The
Size of
resistance.
it,
They all look the same physically.
yeah. They're made up of carbon type, right? And they have an enamel outer coating with the colours painted on it. We're going to also, we get 2% of 5,500, which is, say, 5,500 divided by 100 multiplied by 2.
What are they? What are they? What is that?
Which is 110 ohms, which gives us, it can vary from up as far as
350?
4 to 350
What do you make there?
to 5,000. 5,610
Yeah.
ohms. So it's 110 ohms of a variation. So the reason why you get percent tolerance is if you measure that with an ohm meter, you can only get anywhere between the two of them. So you'll never get two resistors exactly the same. So we'll work out 10% of 2 million, which is 20,000. So you'll have 2 million. 2,000. It's 200,000, sorry.
2,200,000.
Yep.
Yeah.
You just drop this in the point.
Yeah.
So 2 million, and you revert it back to 3. So 10% is 200,000. So that will give you a value anywhere between 2,200,000 to 1,800,000 ohms. This is where your tolerances come into effect. And you have 5% of 5,000, which is 5,000 divided by 100 multiplied by 5 is 50 by 5, 200. 250?
Yeah,
250 ohms.
but that's cheaper, right?
So that gives us a value anywhere between 5,250 ohms to 4,750 ohms. Yeah. So basically